Landscape analysis. Landscapes are shaped by the interaction of social and ecological systems. Brunkhorst, 2005. Current and future use of land, productivity and patterns of sustainability are continually modified by humans within the landscape in spatial scales across time in different magnitudes. Ono et al., 2005. For environmentally focused transportation planning, ecoregions and hydrological watersheds are key concepts that must be considered in landscape analysis. Understanding landscape and watershed characteristics, the geographic context of sensitive environmental resources, and the services provided by natural systems, is vital to providing balanced solutions for sustainable development amidst natural resources that face economic and social issues. Despite the similarity in some points of view between creating subdivisions of ecoregions and watersheds, a common misunderstanding of each of these landscape subdivision frameworks has resulted in inconsistency in their use and, ultimately, to ineffective application in addressing landscape analysis. O'Mernick and Bailey, 1997. Geographic object-based analysis. The traditional methods of classifying remote sensing data are based upon statistical and cluster-based classification of single pixels in a digital image. Lillesand and Kiefer, 2004. Recent research indicates that pixel-based classification methods may be less than optimal in producing high-accuracy land use, land cover maps since they do not consider the spatial relationships of landscape features. Shiwi et al., 2001. For example, a significant proportion of the reflectance recorded for a single pixel is derived from the land area immediately surrounding the pixel. Townsend et al., 2000. Analyzing at the polygon object scale enables imagery classification to move beyond this traditional problem. Contemporary object-based landscape analysis uses parameters derived from hierarchy, context and geometry of the image objects rather than pixel values. Despite a successful history with remote sensing, the accuracy of pixel-based image analysis can be compromised when applied to high-resolution images. Nobrega, 2007. The development and practice of object-based classification has grown as have the variety of methods and approaches of incorporating spatial context into the classification process. Most object-based approaches complement the axiom of landscape ecology, that it is preferable to work with a meaningful object representing the true spatial pattern rather than a single pixel. Blaschke et al., 2001. Furthermore, the development or use of objects, at one or multiple scales, is always an initial primary phase of the analysis which emphasizes capturing, extracting, or refining the size, shape, and distribution of features of interest. Object-based classification can be functionally decomposed into two major steps, segmentation and classification. In the segmentation step, relatively homogeneous image objects, polygons, are derived from both spectral and spatial information. Binz et al., 2004. In the classification phase, image objects are labeled as to their class membership by using established classification algorithms, knowledge-based approaches, fuzzy classification membership degrees or a combination of classification methods. Sivko et al., 2002. The commercial software package, Trimble eCognition Developer, formerly Definions Developer, has been well received as a tool for performing object-based classifications of land cover. An example list of scientific papers using eCognition for various land cover mapping tasks is available at http://www.ecognition.com/learn/resource-center/show more. Type equals scientific %20 paper. For automated generation of segmentation objects, the application uses a region-growing multi-scale segmentation algorithm for the delineation of image objects. The application also enables pre-existing spatial features to be used as objects within which segmentation may be constrained. eCognition provides two different classification methods that may be used separately or combined, a sample-based nearest neighbor classifier with fuzzy logic capabilities and a classifier that enables the development of hierarchic class membership through a set of rule-based fuzzy logic membership functions. This lecture presents an implementation of constrained segmentation in which naturally occurring objects provide the initial basis for identifying relevant features on the landscape within which classification and analysis that implement GBA theory are explored. No segmentation objects are computed, since the objects of interest, watersheds and wetlands, already exist, and segmentation statistics are generated for these areas and used in subsequent phases of analysis. The method combines intrinsic and extrinsic information extracted from the objects, and the analyses are organized hierarchically.